Hello, good morning. Today we'll start a new part of a linear programming problem. Actually, how to solve the linear programming problem by graphical method. So this is the lecture outline and model formulation and graphical solution method and linear programming model and solution. Solving linear programming problem with Excel or with any other software. Actually, a model formulation we have studied in our previous lecture, and we have also formed different model of linear programming problem in our previous lecture. So today we will start only with only graphical solution method. So what is linear programming problem? A model consisting of linear relationships representing a firm's objectives and resource constraints. So LP means linear programming is a mathematical modeling techniques used to determine a level of operational activity in order to achieve an objective subject to restrictions called constraints. So there are different types of actually linear programming problem: a transportation problem, product mix, transshipment, aggregate production planning, assignment problem, multi-period scheduling, blending, diet problem, or food problem, or uh, uh, actually a diet of a diabetic patient, or a newborn baby, or an old man or patient. And investment or capital budgeting also a one types of model of linear programming problem. Another data development analysis, shortest route, maximal flow, trim loss, facility location, set converting, etc. There are many types of linear programming problem. So then linear programming model formulation. Actually, decision variables and mathematical symbols representing levels of activity of an operation. Objective function, a linear relationship reflecting the objective of an operation. Most frequent objective of business firm is to maximize profit or minimize cost or maximize revenue, etc. So most frequent objective of individual operational units such as a production or packaging department is to maximize or minimize cost. And constraints, a linear relationship representing a restriction on decision making. So this is actually a linear programming model formulation. Which we have to optimize z equals to c1 at x1 plus c2 x2 plus dot dot cn x1, where x1 x2 dot dot xn are all our inputs variable or decision variables. And for the first one, for the first shipment, decision variable is c1 x1 and cost will be c1. Then for the second input x2, the cost will be c2 and dot dot. For the xn inputs, the cost will be Cn. This is why all cost will be sum. This will be contained with the objective function. And subject to this is all are linear inequalities and less than or equal to or greater equal to B1. Okay. A21 x1 plus a22 x2 plus dot dot a2 and xn less equal to or greater equal to B2 dot dot. There are n number of linear equations. Okay, where x, z is the decision variables, z equals to 1 to n, and bi are the constraints level, where I equals to 1 to m. Okay, 1 to dot dot m. There are m number of equation here and n number of variables. Remember it. M number of equations, n number of variables. So Cj is the objective function coefficients. It is the cost also. Aij constraint coefficient. You have to remember this. This is the actually general form of linear programming problem. Now, an introduction to linear programming problem. Actually, many management decisions involve trying to make the most effective use of organization resources. Resources typically include machinery, labor, money, time, warehouse space, or raw materials. Resources may be used to produce products such as machinery, furniture, food, or clothing, services such as schedule for shipping or production, advertising, policies, investment decisions. Linear programming is a widely used mathematical technique designed to help managers in planning and decision making relates to resource allocation. Okay. Despite the name linear programming and the more general category, techniques called mathematical programming have very little to do with the computer programming. Okay. In the world operational research, programming refers to modeling and solving a problem mathematically. Computer programming has, however, played an important role in the advancement and use of linear programming to solve the real-life LP problem. And this is also, we can write the general form of mathematical program or linear programming model in a short form. Maximize or minimize, general form of linear, z equals to f of x1, x2 dot dot xn, and all the constraints of n number of linear equations, okay, m number of linear equations with n number of decision variables can be written as like this. And this is called actually constraints or limitations. And xj, where z equals to 1 to n, all xj are non-negative. Okay, this is called also non-negativity restriction. Okay, so whole general form of linear programming model actually consists of three parts. One is objective function, z equals to minimize z. This is objective function, and n number of equations with m number of variables, decision variables, is called constraints, and the last one, non-negativity restrictions. Okay, these three part combinedly called general form of linear programming problem. So where x, j are called decision variables, these are things that you control and you want to determine its value. And z I x1 to xn up to n decision variables are called structural or functional or technological constraints or limitations, okay, or conditions. Okay, xj will be non-negative or non-negativity restrictions or non-negativity constraints, and the function we have to optimize or maximize or minimize is called the objective function. We have to remember this one. So now we'll try to solve how to solve linear programming problem by graphical math. Okay, now we'll try to solve these 5 problems. Actually, there are 5 problems. And first problem, maximize z thrice x plus thrice y, and subject to the constraints, only 2 constraints here with 2 decision variable. And this is the non-negativity restriction. Similarly, number 2, also minimize z equals to thrice x plus twice y, and subject to the constraints 4x plus 11x plus 5y greater equal to 75, 4x plus 15y greater equals to 80, and x, y are the actually non-negative restrictions. Similarly, 3 and 4 also maximize and minimize problem. And last 5, number 5 problems, there are 3 constraints with 2 decision variables. So now we will try to solve this problem on board. Okay, now we'll try to solve the first problem here. Actually, this problem here actually maximize z equals to thrice x plus thrice y, and this is the objective function, and subject to x plus y less equals to 12, and thrice x minus y less equal to 8, and x and y, there are two decision variables, which is called non-negativity restrictions. Now first of all, solution, how to solve solution the problem. Okay, actually we need to solve this problem by applying some steps. First of all, step 1. Step 1. Step 1. Step 1. Making the above inequality. Making the above inequality to the equality equations. Okay. Equality equations, we get x plus y equals to 12 thrice x minus y equals to 8. Okay. Just making this inequality to equality equations. So we are giving this number equation number 1 and this is equation number 2. Okay. Now step 2. Step 2. In step 2, what we have make, let x be along x-axis, okay, and y be along y-axis. Y be along y-axis and draw the graph of equation 1 and 2. Okay, you have to draw the graph of equation 1. How? From equation 1, we can write a box. Okay, this is the box of x and this is the box of y. So suppose for equation 1, if y equals to 0, then x equals to what? 12. Okay. If x equals to 0, then y equals to 12. Just putting y equals to 0, we get x equals to what? 12. Similarly, putting x equals to 0 in equation 1, x equals to 0, then we get y equals to also 12. Okay. Therefore, the points A, suppose 12, 0 and another point 0, 12 exist in line 1. Okay, in equation 1. Similarly, from equation 2, we can draw another box like that. Similar box. One is for x coordinate and another for y coordinate. Similarly, putting y equals to 0 in equation 2. Y equals to 0 in equation 2, we get thrice x equals to 8. So x equals to what will be 8 by 3. Okay, 8 by 3. Similarly, putting x equals to 0 in equation 2, we get y equals to minus 8. Y equals to minus 8. In that case, we get the another 2 points. Therefore, the points C 8 by 3, 0 and D will be 0, minus 8 exist in line 2. Okay, we get this box from equation 2 and first box from equation 1. Now step 3. Now we get easily, we can use the step 3 now. Okay, step 3. Okay, after step 2, we get step Step 3 will be you can draw the graph. Okay, you can draw the graph of equation 1. How we can draw the graph? Suppose we are taking this y axis, and this is the x axis. Okay, what's the value? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, up to 12. And here, actually, how many? 1, 2, 3, 4, 5, 6, 7. Okay, 7, 8. Okay, actually, maximum value 12, and here maximum value of x 12, and minimum value of 8, and maximum value of y also 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, this is the x-axis, and this is the y-axis. This is the origin here, negative x coordinate, negative y coordinate. So now we can plot the value of a. A equals to what? 1, 2, 3, up to 12. This is the point a point, 12, 0. Similarly, B point, what will be? 0, 12. 1, 2, 3, that means this. B point, 0, 12 we get. Okay. Now, if we join these two points, this point and this point, with a span, okay, we get, this is the equation number 1. Okay. But the inequality sign was actually less equal. So this is why for less equal to inequality sign, the solution will exist towards origin. Okay, towards origin. This is the feasible region for line 1. Okay, towards the origin, because less equal. Understand? In our given constants, they are less equal to. If less equals to, the solution exists in the side of actually origin. Okay, now for the second line, C point 8 by 3. 8 by 3 means what? Very near to 3. Okay, near to 3. X below near to 1, 2, 3, near to 3, like this. Okay, now this is the C point 8 by 3, 0. Now another -8. -8 will be 1, 2, 3, up to 3, this point. So if we add this point like this, okay, this is the C point. Okay, this is the C point, and this is the D point. D point what? 0, -8. Actually, this direction, what, in which direction solution exists? Actually, towards origin. Okay, towards origin. So here we get actually this shaded region. This shaded region will be the main source of solution. Okay, this shaded region, because this shaded area will be the area of both lines. Okay, and both lines coincides with this area. This is why there is an intersection point here. Suppose this intersection point is F. Okay, actually this is the line equation line 2. Okay, so now if we solve this two equation, remember equation 1 and 2, if we want to solve these two equations, we get our solution. Okay, how we can solve this actually? Okay, suppose equation line 1 was what? X plus y equals to what? 12. Equation line 1. Okay, another one, what? Thrice x minus y equals to 8, right? So this was equation 1, and this was equation number 2. So adding 1 and 2. So if we add, we get y will be cancelled, right? Y will be y will be cancelled. So we get 4x equals to what will be 20. Therefore, x equals to what? 20 divided by 4, 5. Now, from equation 1, putting x equals to 5 in equation 1, we get what? 12 minus x. That means 12 minus 5 equals to what? 7. Therefore, the intersection point of equation 1 and 2 will be 5, 7. Right? F point will be what? 5, 7. Now, so in step 3, actually we get a feasible region OCFP. Okay. So the feasible solution, therefore, the feasible FEA feasible solution or convex region. Okay. Convex region, what will be OCFB. Okay. These corner points will make this common region. Okay. Which is shaded in the region. Okay. And the corner points are points what? 0, 0. Then C what? 8 by 3, 0. F what? 5, 7. After solving equation 1 and 2, we get. And B point was what? 0, 12. Okay. 0, 12. So these are the actually corner points. So optimum value of Z may attain at the vertex or corner points. Okay, vertex or corner points. So vertex of what? This whole OCFB polygon. OCFB. Okay, this region. So now step 4. Okay. Now step 4. Step 4 will be finding the value of objective function. Finding the value of Z. First of all, vertex or corner points. Okay, corner points. Then objective function value. Function what? Z equals to what was? Thrice x plus thrice y. Okay. Then value of Z. Then minimum value. Okay, mean Z. So this is a table Now, what are the corner points for us? For the polygon OCFB. Okay. The first point, what was O point? O00 point. At this point, value of Z what? 3 into 0 plus 3 into 0 equals to 0. Value of Z what? 0. And C value what? C point. And C point will be 8 by 3 comma 0. Okay. So 8 by 3, Z equals to 3 into 8 by 3 plus this will be not mean values, this will be max values. Max values. So and 3 into 0 equals to only 8. Now F point what? 5 comma 7 and value of Z at this point 3 into 5 plus 3 into 7. This will be what? Actually, after multiplication 3, 5, 15, 3, 7, 21. So 15 plus 21 what? 36. Okay. And B point, OCFB polygon 0, 12. At this point, value of objective function 3 into 0, x equals to 0, and y equals to what? 12. In that case, 36. So this is the actually finding the value of objective function. We get 8 here, we get 36 here, we get also 36. But the maximum value attained at this point here. Okay? The maximum value attained at 36. Okay, because x non-zero and y also non-zero. So this is actually maximum value, and this will be the maximum value of z. But remember that we cannot accept this because x is 0 at this point. Okay, at point B, one decision variable is 0. So for two decision variables non-zero, we get the maximum value 36. Actually, this is the now step 5. Step 5, maximum value of z is obtained at f point 5, 7. Okay, and the maximum value is the maximum value is value of z is what? 36. Now step 6. Step 6 will be optimum solution. Optimum solution is x equals to 5, y equals to 7, and maximum value of z equals to what? 36. Okay. This is the required result. So we can solve any linear programming problem by using these 6 steps. Okay, similarly for another problem, number 2, minimize z. How to minimize the value of z by using graphical method. Minimize z equals thrice x plus twice y, and there are also two constraints, 11x plus 5y greater or equal to 7. For minimum problem, we are using greater or equal to, and maximum less equal to. You have to remember this. So a little bit different here. Now solution. how to solve this minimization problem. So solution. Okay. Step 1. First step, we have to use the step 1. Okay. We have to making the above inequality quality to the equality equations. Okay. The equality equations. Equality equations. How 11x plus 5y equals to 75, 4x plus 15y equals to 80. This is equation number 1 and this will be equation number 2. So now step 2. Step 2 will be we have to let x be the along x-axis and y be along y-axis. Okay. And draw the graph. Draw the graph of equation 1 and 2. How we can draw the graph from equation 1? From equation 1, we can draw, we can plot 2 points. One is x, another is y. Okay. Suppose y equals to 0 in equation 1. Okay, then x equals to what will be? If x equals to, sorry, y equals to 0, then if x equals to 0, then we get y equals to, if y equals to 0, then we get 75 by 11. Okay. If x equals to 0, then y equals to what? 15. 75 divided by 5, what? 15. Therefore, the points A, M is what? 75 by 11, comma 0, and B point what? 0, comma 15 exist in line or equation 1. Okay, line 1. Again, from equation 2. From equation 2, how we can find the points? Similarly, draw the box. One is x, another is y. Okay. If y equals to 0 in equation 2, y equals to 0, then 4x equals to 80. Okay. So x equals to what will be? 20. Now, if x equals to 0, then y equals to what will be? Y equals to 80 by 15. Okay. So we get easily 16 by 3. Okay. 16 by 3. Therefore, the points C will be what? 20, comma 0 and D 0, comma 16 by 3. Okay. Exist in line 2 or equation 2. Okay. Now, step 3. We have to draw the graph. We have to Draw the graph. Step 3. Step 3. Now, if we take the graph like this, just for plotting A, B, and C, D, suppose this is the graph, and here maximum value of x is 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20. Okay, this is the x-axis. Okay, now this is the 0, 0 or origin. Okay. And so now highest value of y, what? Highest value of y actually 75 by 11 or 16 by 3, what? 75 by 11. 75 by 11 means actually about very near to 7. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is the value of y-axis. Okay, and this is the negative part of x-axis and negative part of y-axis. So now we want to plot the point A. This is very near to 7. Okay, very near to 7. X equals to what? 1, 2, 3, 4, 5, 6, 7. Okay, this is very near to 7. This is the A point. And another point y below, what will be on 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so this is the 15. Okay, now this is the A point. A point what? 75 by 11, comma 0, and B point what? 0, comma 15. Okay, so if we join this line, this is the equation number 1. Okay, now in the given inequality, greater equal to. So the side will be opposite to origin. Okay, opposite to origin, what? This one. Because this is the minimization problem. Okay, opposite to origin. This is the shaded part. Okay. Now another point C. C point what will be? This one. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This is the C part. So 20. Now another D 16 by 3. 16 by 3 very near to 5. Okay, more than 5. So 1, 2, 3, 4, 5. This one. Okay, this just joining these 2 points. Okay, we get easily. This is the equation number 2. Okay, equation number 2. And this point what? D, C point. Okay, C point 20, comma 0. And this is the D point. Remember it. D point. D point what will be? 0, 0, 16 by 3. Okay, 0, 16 by 3. This is the D point. 0, 16 by 3. Or we can write this as the D point first. Okay, D point means what? 0, 16 by 3. Now this also shaded part will be what? Opposite to the position of origin. Okay. Now which will be the shaded part? Shaded part will be this. And both line. This is the shaded area. Okay. This is the shaded area. And within the shaded area, we get the corner points, these 3 corner points. Okay. Remember that in this part, equation number 1 not line. Okay. And in this part, equation number 2 not line. This is why these both lines exist in this region. This is why this is the shaded region for us. Shaded region will be now for this one, the convex solution, the convex, the feasible solution region or convex region is what would be C. This at this point we can denote F. CFB. Okay? CFB. But how we can find the B point, F point? This is the intersection point of line 1 and 2. Okay, we have to solve this 2, 1. And the coordinate, the vertex or corner points. Corner points, what will be C point what? 20, 0. F point we have to find out. And B point what will be? 0, 15. This is the 0, 15. Now, how we can solve line equation 1 and 2? Here we have actually line 1 and 2. How we can solve this one? Okay. We are given 11x plus 5y equals to what? 75. This is equation number 1. Okay. And another one, 4x plus 15y equals to 80. This is equation number 2. Now we will try to solve this one. So how we can solve? Actually, if we want to multiply equation 1 by 3, then we get 15y. Okay. Then subtracting equation 2. Okay. Suppose 33x multiplying by 3 in equation 1. 33x plus 15y equals to 3 multiply 75 what? 225. Just 4x plus 15y equals to 80. Now subtracting. Okay. Subtracting we get 29x equals to what? 29x equals to 5, 4, 145. Okay. Therefore, x equals to what will be? X equals to 5 multiplied 29. Okay. Therefore, 5. Now putting equation value of x in equation 1, 5y equals to what will be? 5y equals to 75 minus 11x. Okay. 75 minus 11 multiplied 5. 75 minus 55. That is what? 20. That means 5y equals to 20. So y equals to what will be? Y equals to 4. Now we, by elimination process, we have solved equation 1 and 2, and we get the solution is what? Solution is equation number solution equation and 1 and 2. What? Solution 5 comma 4. Okay, so we can write 5 comma 4 here. Okay, now step 4. Step 4. So in step 4, how we can find value of, just we have to find out the value of z. Okay, just draw, we have to draw the finding the value of z. Okay, first of all, corner points, corner points or vertex points, then objective function, value of z, mean z, okay, minimum z values. Just we have to draw the same table. Okay, objective value z equals to what was? Twice x plus twice y. So the second number. Okay, now first point what was? First point C point. Okay, first corner point C from the shaded region 20 comma 0. Okay, value of z at this point 3 into 20 plus 2 into 0 equals to what? 60. Value of z is 60. Similarly, f point, at f point what? 5 comma 4. So value of z will be 3 into 5 plus 2 into 4 equals to what? 3, 5, 15 plus 4 into 2, 8. So 15 plus 8 what? 15 plus 8 will be 23. Okay, 23. And another corner point what? P point 0, 15. So at this point, value of z what will be? Value of z 3 into 0 plus 2 into 15 equals to what? 30. We get 30. So from this, we get the minimum values obtained at point what? F point 5 comma 4. The minimum value of z will be what? 23. Okay, star point. Minimum value of z is what? 23. Now step 5. Step 5 will be step 5. Step 5 will be same as the previous example. Step 5, minimum value of z obtained at what? F point. Okay, f point 5 comma obtained at f point, and the minimum value of z and the minimum value of z is what? 23. So step 6, the optimum solution. Optimum solution or value of that is what? 23. Okay. Value of z is 23 and solution x equals to what? 5, y equals to. This is the complete result. Now problem number 3. If the decision variable is denoted by x1 and x2, that means x variable and y variable. Okay. Maximum z equals to 5x1 plus thrice x2 subject to 5 thrice x1 plus 5x2 is equal to 15, 5x1 plus twice x2 is equal to 10, and x1 and x2 are the non-negativity restrictions. So solution will be like this. First of all, step 1. Okay, step 1. Making the above inequality to equality equation. We get what? Thrice x plus thrice x1 plus 5x2 equals to 15, 5x1 plus twice x2 equals to 10. This is equation number 1 and this is equation number 2. Now step 2. Sorry, we have to find out the coordinates before that. From for equation 1, okay, you can draw the box x, y. Now if y, it will be x1 and this will be x2. Okay, just in the place of y, we are putting x2 and in the place of x, we are putting x1. Okay. So if we put x2 equals to 0, then x1 equals to what? 5. But if x1 equals to 0, then x2 equals to what? 3. Okay. Therefore the points A will be what? 5, 0 and B 0, 3 exist in line 1 or equation 1. Okay. Again for equation 2, similarly drawing the box, one is x1 and other is x2. Okay. So if x2 equals to 0 in equation 2, then x1 equals to only 2. Okay. 5x1 equals to 0. If 5x1 equals to 10, then x1 equals to 2. But if x1 equals to 0, then x2 equals to what? 5. Okay. In that case, the points C points, what will be? 2, 0 and another point D 0, 5 exists in line in second line. Okay? Second line. Okay? Because this we got from second line and this box got from first line. Now step 2. Step 2 will be what? Step 2. Let x1 along x-axis and x2 along y-axis. Okay? And draw the graph of equations 1 and 2. So how we can draw the graphs? This is the x-axis and this is the y-axis and this is the origin. Okay. So highest point of x1 is 5 and x2 is also 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, for the first point, A point, 1, 2, 3, 4, 5. X equals to 5 and y equals to 0. So this is the point. A point what? A point will be for the point A, 5, 0. This is the 5, 0 point. We get A point what? 5, 0. And B point what? 0, 1, 2, 3. Okay. This is the C point. This is the C point. We can add this. This is the C point. C point. Okay. Now, this is the equation number 1. And second equation will be for C. Sorry, this will be D point. This will be the D point. Now, for the C point, x equals to what? 2. This is the C point. 2, this point, and D is 0, 5. D will be this. Okay, 0, 5. So we can easily draw this. This is the C point. Okay, and this is the D point. Now remember that the inequality sign was less equal to. So if the sign is less equal to, then the shaded part will be along the origin, and here also along the origin. So remember that this is the shaded region for us. In this region, our feasible solution exists because the shaded part is how many corner point here? 1, 2, 3, 4. This corner point, suppose F. So F point will be the F point. What will be? Intersection point of equation line 1 and 2. Equation line 1 what? Thrice x 1 plus 5x2 equals to 15. 5x1 plus twice x2 equals to 10. This is equation number line 1 and this was equation number line 2. Okay. So this equation 2 line, we can after solving this part, we get the intersection point 5. How we can solve? Just equation line 1 multiplying equation 1 by 2 and 2 by 5. 2 by 5. How? Multiply equation 2 with multiplying equation 1 by 2. What? 6x1 10 x2 15 multiplied to 30. And equation 2 by 5. 25x1 10x2 and 5 multiplied 10 will be 50. Now subtracting we get 6 minus 25. What will be? Minus 19x1 equals to minus 20. Therefore, x1 equals to what? 20 by 90. Right? Now, from equation 1, 5x2 equals to what? 15 minus thrice x1. So, 5x2 equals to 15 minus 3 multiplied 20 by 90. So 5x2 equals to what? 15 minus 60 by 90. So dividing by 5 on both sides and taking LCM, we get 45 by 90. X2 equals to what? X2 equals to 45 by 90. That means F point will be what? X1 what? 20 by 90 and 45 by 90. Okay. And this is the shaded region for us. Now step here the feasible region. Here the feasible region. What will be? O, C, F, B. And the vertex point. And the vertex point here the feasible region OCFP and hence and then vertex point or corner points what will be 0 0 0 0 C point what? C point 2 comma 0 and F point what? 20 by 19 45 by 19 and last point B will be what? 0 comma 3. Now step 3. This is the step 3. Okay. Now step 4. Step 4 will be the finding the value of Z. Finding the value of Z. How? Just vertex point or corner point. Vertex point or corner point. Value of objective function. Objective function. Z equals to what? Z equals to 5x1 plus 3x2. 5x1 plus 3x2. And value of z max value. Okay, max of z. So this is a table for us. Similar table for every problem. Now for the first corner points, what would 0, 0? Value of z will be 5, 0, x1 equals to 0, x2 equals to 0. Okay, 3, 0 equals to 0, value of z will be 0. Now, second corner point, 2, 0. Okay, second corner point, C point. So at this point, 5, 2 plus 3, 0. This equals to 10. Okay. Now, another point, F point. F point what? F point. F point will be 20 by 19, 45 by 19. So we get value of z at this point. Value of z at this point. 5 into 20 by 19 plus 3 into 45 by 19. And this value of z will be 335 by 19. 335 by 19. 335 by 19. Okay. Actually, this will be the maximum values. Now another point B. B point will be 0, 3. At this point, value of z will be what? 5 into 0 plus 3 into 3 equals to what? 9. So 9. So actually maximum point will be 335 by 19. So the maximum value of z what? 335 by 19. This is the result which can attained at the point F. At the point F point. Okay. Now step 5. Step 5 will be step 5. Step 5 will be the minimum value of z is obtained at f point 20 by 19 x1 and 45 by 19 x2. Okay, and the maximum value is not minimum. Next, and the maximum value is 335 by 19. Okay, 335 by 19. Step 6. Optimum solution is x1 equals to 20 by 19 and x2 equals to 45 by 19 and max z equals to 335 by 90. This is the actually result for us. Now similarly problem number 4. This is the actually minimization problem. First of all, step 1. Making the above inequality to equality equation. Equality equations, we get equality equations. What we get? Thrice x1 plus x2 equals to 9, equation number 1. And another one is x1 plus thrice x2 equals to 12. Okay, equation number 2. So from equation 1, you can draw the box as previous one. So x1 and this is the x2. So if x2 equals to 0 from equation 1, then x1 equals to 3, x1 equals to 9, x1 equals to 3. Now if x1 equals to 0 in equation 1, then x2 equals to 9. Therefore, we get the points. Points what will be 3, 0 and b, 0, 9 exist in equation 1, in line 1. Okay, equation of line 1. Again, from equation 2, from equation 2, again drawing the same box. Okay, x1, x2. If x2 equals to 0 in equation 2, then x1 equals to what? 12. Okay, and if x1 equals to 0 in equation 2, if this is 0, then 3x2 equals to 12 and x2 equals to what? 4. Okay, so therefore the another 2 points, C points will be 12, 0 and D points will be 0, 4. Exist in line 2. Exist in line 2. Now step 2. Step 2. Step 2 will be let x1 along x-axis and x2 along y-axis and draw the graphs of equation 1 and 2. So now we can draw the graph. Highest value of x1, actually 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, this is the x-axis and this is the origin. Highest value of x2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the y-axis. One is a positive one, and this is the negative part, and this is the negative part of x-axis. Now, if you want to draw the equation line 1, a point will be what? 1, 2, 3. This is the a point. Okay. And second point, B point will be 0, 9. 1, 2, 3, 4, 9. So B point is that point, and this is the B point. So joining. Okay. So this is the equation number 1. And this point will be what? This point will be B point. B will be, so this will be A point. Okay. A point 3, 0, and this B point B 0, 9. Okay. Now, inequality sign, what will be? Because greater equal to, this is why this is opposite to the origin. Okay. greater equal to inequalities and greater equal to this, the direction of solution will exist on the opposite part of original. Okay. Now C point what will be 12, 0. 2, 3, 4, 5, 6, 7. This is the 12. Okay. C point. So C 12, 0. And D point will be 0, 4. 1, 2, 3, 4. This is the 4 point. Okay. Now just draw, just joining these 2 points. Okay. This is the equation number line 2. And this is the actually D point. Okay. D point. This is the D point. And 0, 4 point. Okay. This direction will be also opposite to the origin, side of origin. Okay. So this is the common region we get. This is the common region. Okay. How many corner point here? Only 3 corner points. Suppose this point is F. Okay. And this F point can be found by solving the equation number 1 and 2. Okay. How we can find the intersection point of line 1 and 2? Actually, line 1 was what? Thrice x. This is the solution part. Thrice x1 plus x2 equals to 9. This is equation number 1. And another one was x1 plus 3x2 equals to 12. Equation number 2. So this is just solving. How we can solve this? Suppose in equation 1 multiplying by 3, then subtracting equation 2. Okay, multiplying 1 by 3, 9x1 plus 3x2 equals to 27. Then subtracting equation number 2 equals to, how we can get 3x2 cancel after subtracting. Okay, so 8x1 equals to what will be 15. Okay, so x1 equals to what will be 15 by 8. Now putting the value of x1 in equation 1. Okay, putting the value of x1, x2 equals to what will be 9 minus thrice x1. So 9 minus thrice into 15 divided by 8. That means 9 minus 45 by 8. So we get, taking LCM, we get x2 equals to what? x2 equals to 27 by 8. Okay, taking LCM. So the solution we get x1 equals to 15 by 8 and x2 equals to what? x1 comma x2 equals to what? 15 by 8, 27 by 8. Okay, 27 by 8. So the solution we can write now, the intersection point F, we get what? 15 by 8 comma 27 by 8. Fifteen by 8 and 27 by 8. Therefore, the feasible region will be what? CFB. Okay, CFB. And the corner points, vertex or corner points are CD what? 12, 0 and F point what? 15 by 8, 27 by 8, x1 and x2. Okay, and B will be 0, 9. Now step 3. Actually, this was the step 3. So this will be a step 4. Okay. Minimum value of Z, finding the minimum value of Z. How? Vertex point Z value what? 7x1 plus 8x2. Next one of the value of Z, then mean Z. Okay. So the table just look like this table. Okay. Now just putting the value of points, we can find out the value of Z. Okay. Now, but first vertex point C 12, 0. Z value what? 7 multiplied 12 plus 8, 0. So value of Z will be 84. Another F point 15 by 8, 27 by 8. Okay. Z value what will be? 7 multiplied 15 by 8 plus 8 multiplied 27 by 8. Then we get, actually, after simplification, we get 321 by 8. Okay. Now another point, vertex point P, 0, 9. So Z, value of Z will be 0, 7 into 0 plus 8 into 9. That means 72. Actually, the minimum value is this one. This one is approximately 40.125. So minimum value of Z what? 321 by 8. Okay, 321 by 8. And this value obtained at this point F. Okay, the minimum value of Z attained at F point. Now step 4, step 5. Step 5. Step 5 will be what? Minimum value of Z is obtained at what point? F point. 15 by 8, 27 by 8. And the minimum value and the value of Z is what? 321 by 8, which is very near to 40.125. And this is the minimum value of Z. Step 6. The optimum solution. Optimum solution is x1 equals to what? 15 by 8. Okay, 15 by 8. And x2 equals to what? 27 by 8. And minimum value of Z equals to what? 321 by 8. This equals to what? 40.125. This is actually our desired result. Now the last problem, this is the final problem of this class. Actually, there are three constants, x1 plus x2 less equal to 4, and this the constants and objective function of 5x1 plus 7x2, and non-negative restrictions will be x1 and x2 greater or equal to 0. Now, step 1. So for the solution, first step, we have to convert the inequality to equality equation. So making the above inequality to equality equations. Okay. So we get three equations at a time. 4x1 plus 8x2 equals to 24. This will be 8. And 10x1 plus 7x2 equals to 35. So this is equation number 1, and this is equation number 2, and this is equation number 3. So we get actually three equations at a time. Now step 2. So for line 1, you can draw for equation 1. Equation 1, we can draw a box. One is x1, another is x2. So if x1 equals to x2 equals to 0 in equation 1, then x1 equals to 4. But if x1 equals to 0 in equation 1, then x2 equals to 4. So the points, therefore, the points are A, B, 4, 0, and B, 0, 4, right? This will be the joining line. And exist in equation 1. Okay. Similarly, next line for equation 2. For equation 2, we can draw another box. One is x1, another is x2. Okay. So if x2 equals to 0 in equation 2, x1 equals to what? 24 by 3, 8. And if x1 equals to 0, then 8 equals to what? And 8x2 equals to 24. So x2 equals to 3. Therefore, the point C will be 8, 0, and D point will be 0, 3 exist in line 2, okay, or equation 2. And for equation 3, you can draw the same box for finding the points x1 and x2. So if x1 equals x2 equals to 0 in equation 1, so equation 3, if x2 equals to 0, then we get x1 equals to 35 by 10. That means we get 7 by 2, right? 7 by 2. And if x1 equals to 0 in equation 3, then we get 7x2 equals to 35. So x2 equals to what will be? So the points E point what will be 7.2 and F point will be 0,5 exist in equation or line 3. Okay. So now step 2. Let x1 along x-axis and x2 along y-axis. Okay. x1 along x-axis and x2 along y-axis, and draw a graph of equations 1, 2, and 3 at a time. Now, how we can plot? Actually, we can plot the equation like this. For the first point, we got a point 4, 0. Actually, highest point of x1 is 8. 1, 2, 3, 4, 5, 6, 7, 8. This is the x-axis and this is the origin, and this is the negative part of x-axis. Now, highest value of y actually, or x2, 5. 1, 2, 3, 4, 5. So this is the actually y-axis, and the part of y-axis is this. Now, just you have to find out a point. A point 1, 2, 3, 4. This is the point, and B point also 1, 2, 3, 4. This is the B point. So joining these two, this is the A point, and this is the B point. Okay. This is the line 1. Line 1. Now, C point, what will be 8, 0? This is the 8, 0. C point, and D point will be what? 0, 3. This one. So we easily join these two points. It is the C point, and this is the D point. Okay. D point. And their direction will be along x-axis. This is the maximization problem. This is why, because less equal to. So direction will be what? This, along the side of origin. Now, E point 7/2 means what? Actually 3.5. That means 3.5 will be like this. Okay. Sorry. This is the y-axis. 1, 2, 3. 1, 2, 3. 3.5 means this one. Okay. And 5. This will be the 5. So this point will be the what? E point. Okay. E point, and this will be the F point. F point. Now just joining this one. Okay. Joining this one. And this direction will be also, this is equation number 3. equation number 3. This one 4 exists like this, and 5 point this one okay. This is the actually feasible region here. Okay, this feasible region we get there are 3 intersection point. One is line 1 and 2. Okay. Line 1 and this is the line 1 and 3. Okay, line 1 and 3, and this is the line 2, the line 2, and this is the line 2 and 3, and this is the line 1 and 3. Sorry, 1 and 2. Okay, so there are 3 intersection point. Suppose into 3 intersection point is L. Suppose this is L, M, P. Okay, L, M, P. Now, how we can find these intersection points? L, M, P. Okay, this is the feasible region for us. Okay, now L point is actually L point. For L point, we have to solve what? For the point L, actually equation 1 and 2. Solving equation 1 and what? 2. So equation 1 and 2 solving just. That means x1 plus x2 equals to what? 4, and 3x1 plus 8x2 equals to 24. This is equation number 1 and this is equation number 2 in our problem. Now multiplying 8 multiplying, then subtracting equation 2. How we can get 4x1 plus, so 8x1 8x2 equals to, then 3x1 plus 8x2 equals to 24. Subtracting, we get 5x1 equals to 8. Okay, so x1 equals to what? 8 by 5. Now putting the value of x1 in equation 1, x2 equals to what will be 4 minus x1, 4 minus 8 by 5 equals to 12 by 5. Therefore, L coordinate will be what? 8 by 5, 12 by 5. Okay. Another point, L, M point. M point will be actually, this is the intersection point of 3 and 2. Okay, 3 and 2. M point will be intersection point of M point. Intersection point of intersection point of what? 2 and 3. 2 and 3. Just solving 2 and 3, we get the M point. M point. And another point, P point is the intersection point of what? 3 and 1. Okay, 3 and 1. Remember this. 3 and 1. And P point intersection point of what? Of 1 and just solving 1 and 3, we get one equation what? X1 plus x2 equals to 4. 3 equation what? 10x1 plus 7x2 equals to 35. Equation 1 and equation number 3. So multiplying equation 1 with 7 and subtracting equation 3. Okay. So we get 7x1 plus 7x2 equals to 28. 10x1 plus 7x2 equals to 35. So subtracting, we get minus 3x1 equals to minus 7. Okay. Therefore, x1 equals to 7 by 3. Right? And x2 equals to what will be? x2 equals to 4 minus x1 equals to 4 minus 7 by 3. That means equals to 5 by 3. Therefore, point P, we got what? 7 by 3, 5 by 3. Now, step 3. Step 3. The feasible region is what will be? The feasible region will be OA OA B L B L and D. Okay. So, and the corner points, the vertices or corner points, what will be? 0, 0. A point will be what? A point will be A point will be 7/20, and B point will be what? 7/3, 5/3, and L point was what? 8/5, 12/5, and D point will be 0.3. Okay. Now finding the value of Z step. Finding the value of Z. Z what will be? Now finding the value of Z. First vertex, then Z value, objective function, what 5x1 plus 7x2, 5x1 plus 7x2, then values of Z, then max values. Okay, max value. So this is the table as previous example. First vertex what? 0, 0. Z value what? 5 into 0 plus 7 into 0 equals to 0. Now another value A will be 7/2, comma 0. Z value what? 5 into 7/2 plus this equals to 35/2. Now for P point, 7/3, 5/3. Value of Z will be 5 into 7/3 into plus 7 into 5/3. So at this point, Z value will be 70/3. And for another point, L, 8/5, 12/5, when value of Z what will be? 5 into x1 equals to 8/5 plus 7 into what will be 12/5. So after calculation, we get Z value 124/5. 124/5. Now another point, D point 0, 3, value of Z will be 5 into 0 plus 7 into 3 equals to, we get 21. So which is actually maximum value here? Actually, maximum value is this, and it attained at point L. Okay, L point. Attained at the point L. Now step 5. Step 5. Step 5 will be, step 5 will be the maximum value of Z attained at L point. 8/5, 12 by 5. And maximum value of and maximum value of z is what? 124 by 5. 124 by 5. Now step 6. Last step. Steps. Last step will be step 6. The optimum solution is x1 equals to what? 8 by 5 and x2 equals to what? 12 by 5. And maximum value of z equals to 124 by 5. This is actually our desired result. Okay, thanks to everybody. I hope if you do practice more and more, only these 5 problems, you can solve any types of linear programming problem. The best wishes for you. Thanks to everybody. So why we need the linear programming problem? These 3 conditions. Now in linear programming applications, this is the applications of linear programming problems. And there are many applications. Just I have selected only 8 applications. The requirements of an LP. This is the requirements to make an LP programming problem. Formulating the LP problem. Okay. Just we can use this real life examples to make an LP problems. This is the department, 3 department, electronic, assembly, and profit per unit. Then X1 is the number of workman to be produced and X2 is another one. So available hours this week 240 and 100. Profit per unit $7 for X1 and $5 for watch TV. So we can formulate the objective function like this, and there are 3 types of constraints. Okay, so we can solve this also graphically like this. Okay, this is assembly constraints P, and this is the shaded region for us, feasible region. Okay, now we can solve easily the intersection point of line 1 and 2. Isoprofit line method. This is the solution for us. This is the iso line. Okay. This is the shaded region. Optimal solution obtained at point x1 equals to 30 and x2 equals to 40. This is the iso line. Maximum profit line. Okay. Maximum profit is $410. Corner point method. I have used the graphical problem, graphical method. This is the corner point method. Okay. For the first point, corner points, the profit is 0. Second corner point, profit is 400 and fourth will be $350. So for solving the intersection of 2 constraints, intersection point, we have to solve the problem. Okay. Now for the another point, x1 equals to 30 and x2 equals to 40, the profit is maximum. Okay. Sensitivity analysis. So this is the sensitivity analysis for this problem. Sensitivity report can use the Microsoft Excel for to make the sensitivity report for this problem. Okay. This is the changes in resources. And in that case, the sensitivity analysis will be change assembly constraints from this. And this is the shaded region. By quarter points, we get the highest profit or maximum profit, $450. Okay. This is also give the solution. And shaded region, we get the profit $405. Changes in the objective function. Solving minimization problem. First of all, we have to formulate this minimization problem example like this. Just plotting the graph, you get the shaded region or feasible region like this. So total cost at A and B, get the lowest cost is at point A. The production mix example. Maximization profit subject to this. Diet problem example. Product, there are 4 products, stock X, stock Y, stock Z. So there will be 3 variables. Okay. So X1, X2, and X3, 3 variables, and 4 constraints, 5 constraints or limitations, 3 decision variables, and we have to minimize the purchase or cost. Production scheduling example is maximizing profit. Okay, this is the actually a real life application of linear programming problem. Labor scheduling example. So first solution, second solution, there are 2 alternative solutions. Now another method is simplex method, very easy method, which is developed by George Dempsey in late 1940. Simplex method. So in our next lecture, we'll try to solve simplex method. So till then, bye for today.